I wanted to invite you to look at a seminar that I'm going to be teaching next semester and see if this is something you might be interested in taking. It's entitled Arduinos for Geoscientists, and basically it is going to be a 1-hour seminar in the evenings on Tuesdays from 5 to 6 o'clock at night, and we're going to be learning about how to use these simple microcontrollers in order to collect data in the geosciences. And so some of you may be familiar with these kinds of things. This is similar to like a Raspberry Pi, and basically what it is it's a little tiny board which you can plug in different kinds of instruments and then log those signals. And this is a really cheap way to do things. This particular board is actually an Arduino knockoff board. It costs about $19. If you want to buy a real Arduino, it's about $25. And so the idea behind this is there's a lot of measurements that we make that we may kind of be getting ripped off by going through a normal company that is marking things up, right? And so there's some instruments that we may be able to make on our own for a very inexpensive price, and these instruments in some cases can work almost as a disposable instrument. So you can use it for a field season, and if it gets destroyed, you're not out a lot of money. And so I just wanted to show you some examples of some of the things that we can plug into one of these Arduinos, and then I want to talk to you just a little bit about why I think you might want to be interested in taking this class, and why in the world I'm qualified to teach a class like this. So we'll get to that in a second. So let me show you my first project that I worked on. This is a breadboard right here. This is an Arduino, and what I have right here is actually a sensor that measures distance. And so if you look on the screen here, and we'll see if we can get this to come in, what you can see is that the distance right now is 27 centimeters from this sensor to my desk, and I put it made by Chris right there. And then as I move this sensor down, you can see it's 22. As I move this sensor up, you can say it's 39. And so here's an interesting sensor. In this case, we actually have one of these deployed in the field that measures water levels of streams. And this whole setup, this sensor actually cost $5 for 2 of them. This whole setup is very inexpensive. The cool thing about this is, in this case, this is just logging to this LCD display. You can put a cell phone shield on this, and you can actually have, and this is what we have in our project. This instrument actually then sends you text messages of what the water level is, and then we record those text messages. And so if you think about this for another application, you may have a heater bath in your lab, right? And that heater bath could be controlled by an Arduino. So the Arduino could use a thermistor cable, like this cable here. It could go into the heater bath, and then your Arduino could also be plugged into your heater. And so as the heat varies, the heater would turn on and turn off and turn on and turn off. And then if you put that cell phone shield on top of it, you could then have your instrument send you a text message telling you, oh no, the temperature dropped below and it's not going up, so there's something wrong. Or you could have or you could set this up in the opposite way, and you can actually send a text message to the Arduino to tell it to turn the heating bath on. So if you have timed heating or something like this, this is the kind of microcontroller that could allow you to do that. Other things that you can look at is, here's a simple, I actually bought this off some crazy website in China. This is a simple soil moisture probe, and so this is a cheap way to do it. The other thing is that we can get expensive soil moisture probes like I would order from Decagon Devices, and I can just cut this wire off right here and plug it right into my Arduino. We can control motors, we can control servos. Here's a shield that allows you to put a SD card in and log to an SD card. The other things that you can do, they have a LiDAR system. It's 99 bucks for this LiDAR sensor that measures distance over long expanses. There's actually a thermal infrared camera that you can attach to our Arduino, and that's like 300 bucks. So that's probably more than our graduate budget, right? But you can also hook up GPS. So if you were interested in the movement of some object, say like, I don't know, we'll throw out a glacier, right? You could have a GPS chip on top of the Arduino, on top of a cell phone shield, and then what can happen is it would record the GPS location, and it would send you a text message of what that GPS location is. For those of you who are saying, this is really cool, but I'm not a programmer, the great thing about this is that this isn't really programming. Pretty much all of these instruments have little snippets of code that you cut and paste and modify, and so that you can adjust things very easily. So I think this is a really great opportunity. What I want to do with this seminar is I don't want this seminar to interrupt your core research. What I want to be is this is just kind of a bonus thing. And so this is why I'm running the seminar from 5 to 6 o'clock at night on Tuesdays next semester. I don't want this to interrupt my day. I don't want this to interrupt your day. I want this to be just gravy. And so this is kind of a bonus seminar. In terms of me teaching this class, these are kinds of things that I fool around with, but the great thing is I have an undergrad TA lined up from computer science. He's been working with me for about a year on programming these kind of boards for processes that I use in my actual research. And so his name's Matt, and Matt's going to come in and he's going to act just like a TA like we are to our students, and he's going to help us with the programming and help us move through these things. The course is going to be split up into two sections, two halves basically. In the first half, we'll do a bunch of little hands-on activities together that'll learn how to kind of program this and use things, and we'll turn on LEDs and we'll look at temperature and we'll look at light and things like that, just simple kinds of things so you get used to the programming. And then in the second half of the class, what I want you to do is I want you to build your own instrument. So I would like you to design and build an instrument that applies to your research or research that you want to do in the future when you graduate here. And so really at the end of the class, what I would like is I would like everyone to have an instrument that they have built on the cheap. There's not going to be a textbook for this. We're actually going to use a set of YouTube videos and some online tutorials on how to program these things. And so what you'll need to do for this class is you'll need to buy one of these Arduino boards, which is, like I said, between $19 and $25. And then any instruments you want to use for your class project, you'll need to buy. So what I would probably do is if I was thinking about budgeting for this class, I'd probably put aside about $100. This setup that I have here that did the depth, this is probably on the order of maybe $45 or $50 to have all this, to have all the equipment here. And then, other things are at different prices. But basically, like I said, if you have an instrument in your lab that you use on a regular basis and it has some cable to it that you plug into a logging device, then that is reading a millivolt change. And the Arduino is meant to read these millivolt changes. And for those of you who are maybe a little more familiar with these things, these Arduinos both have digital and analog inputs. And so that can kind of tell you some of the kind of instruments you can plug into it. So if you have any questions about this, shoot me an email and we can talk about it. I think this is a really cool opportunity, and I think this is something that I'm interested in. And so by no means am I the expert, but I would like to kind of organize a seminar so that we can start talking about this and start maybe building some of our own instruments and thinking about how we can collect spatially and temporally distributed measurements really on the cheap. So like I said, I hope you can join us for this seminar. I think it's going to be a lot of fun, and this is really kind of a new format. And so as a result, I'm trying a YouTube infomercial. All right, have a great day.